Okay, good afternoon, everybody. Thank you for joining this session. Um, so today I want to put my customer hat on and talk about some of the challenges that big customers bring to the table. Right? Regardless if you're $49 billion private equity fund or you're $33 billion media and entertainment company, or if you're $11 billion financial services company, the challenges are pretty common. So first of all, how to navigate this DevOps landscape, right, and provide consistent results that gives you competitive advantage, you as a company. And second of all, how to keep up with these newer emerging technologies, right? Like serverless landscape is offering. Right? Believe it or not, big customers also like playing with new shiny toys. They're not just all about legacy. Right? So what do these big customers have in common? They do love Terraform, and they do have a lot of cloud accounts, AWS, Google Cloud, Microsoft Azure, you name it. So let's see how Terraform helped them in their journey to the cloud. And today I'll try to focus on Terraform specifically and serverless. My name is Eugene. I'm the Chief Technology Officer of Mito Group. So we are a cloud native company. We started 5 years ago when Amazon, AWS launched their first serverless offering, AWS Lambda. These are my credentials. I won't spend too much time on it because the projector is not showing it. Okay, it's all good. So I shouldn't touch my computer. So instead, today I would like to talk about how our team, we as engineers, how we felt overwhelmed with these constantly evolving services and tools, and what small steps did we take in order to keep up with the latest emerging technologies like serverless, right? And how they combine, how they play together with the legacy environments that the customers have, right? So the devil is in details, right? Well, let's face it, we as engineers, nowadays we have a lot of services and tools that we have at our disposal, right? But the exponential growth of these technologies, it's not only like becoming a problem, but it's also an opportunity to use less and to do more by using less, okay? Well, a smart guy once said, when something is important enough, you do it even if the odds are not in your favor. So the history shows that he was right. He was one of my idols. So after a short introduction into the problem and a short explanation into how we're thinking about the problem, let's dive into Terraform for serverless. I just need to make sure that we have the same understanding about these three concepts, right? What does it mean in IT as a service? What's the spectrum, right? What is the DevOps and what's the spectrum? So what is in scope, what is out of scope? As well as, well, scope and boundaries, right? So first, IT as a service spreads across on-prem, co-locations, hosting, infrastructure as a service, platform as a service, software as a service, right? They're all the same. The only difference is, are you as a customer, you're managing your components from this stack, or somebody else, right? The provider is managing for you, or a third party. Now, speaking of serverless, I have seen many definitions. You guys can Google it, or if you're familiar with it, but the one that I personally like and I always bring it up is this one by Adrian Cockcroft. He's a former chief architect of Netflix, and currently he's a VP, vice president at AWS. If your platform as a service can efficiently start instances in 20 milliseconds, that can run half a second, go ahead and call it serverless. So if we go back to the spectrum, right, serverless, we generally assume for serverless that it's talk about platform as a service or software as a service. Everything else is not in scope. Right? Second, DevOps spectrum includes all the development operations that we as engineers need to manage. Right? So we must go through, we need to manage it end to end. Right? So that means having continuous integration, having continuous delivery, continuous deployment, they're definitely in scope, right? And even if you're not doing it or somebody is managing it for you, it's all together end to end. You have to have it under control. And last but not the least, if we go back to that landscape, DevOps landscape, right? And let's say we are marking development services with A, we're marking configuration management and provisioning with B, orchestration and scheduling with C. Terraform is B, but Terraform for serverless is all of these things combined. Okay. So there we go. This is the core of my talk. How to, that's what I'll be talking about, the best practices and lesson learned, and from using Terraform for serverless, okay? So best practice number one is adopt the microservices approach, right? Aim for one-to-one relationship between the Terraform configuration that you are writing and the final destination of your resource in the cloud. Either you're talking to AWS or... I'm bringing this up all the time. Anton mentioned it earlier in his previous talk, right? So just a heads up disclosure, the examples that I will be showing for each of the best practices, it doesn't mean that it's something wrong with it. It means there are a better way to do it, all right? So don't look for an error or something. That's not the point of the examples that I'm providing. Right? So for example, in this case, right, where you have everything put into this service Lambda function, right, all the resources that you need in order to run one Lambda function, instead you can break it down into multiple components, and you have one-to-one relationship. Right? And there's also, Anton mentioned in the previous in his previous presentation, then you can use orchestrations, then you can put dependencies across them, then you can use them in CI/CD pipelines, and so on and so forth. After you break down your environment into this kind of microservices architecture approach, right? You can use built-in functionality to pass actually variables across your resources. Right? This is a built-in feature. It's called Terraform Remote State. Although it has the name of remote state, it doesn't mean the state needs to be remote. So here's an example. So you have here two different Terraform configurations. In both of them, I need to specify, let me see, I need to specify here the role name, okay? So I use two different services and I need to specify the role name in them, right? So instead of hard coding the name into both of them, you can put the, like in the previous example, the name of the role I'm having in my IAM, and then when I write my Lambda function, I'm actually referencing to that value by reading the remote state, okay? By the way, if you guys have any questions, feel free to stop me anytime, ask questions. You don't, oh, Sorry. Yeah, we have that application. Yeah, I'll answer the questions at the end. Write the question in the application. What's worksup.com. Okay, next. The third best practice is to avoid using provisioners. Anton also mentioned in his previous talk, as well as external data. So the external data is something similar, gives you the same functionality, where you can very easily get into loops where you're calling in Terraform some other stuff that Terraform spits out. Right? Instead, use the orchestration tools. Here's an example. Instead of, so for example, I have my Lambda function, but before I create my Lambda function, I need to compile my code, because Lambda you need to provide to AWS Lambda a zip file. You cannot just provide the JavaScript, right? Instead of that, you can use a tool like TerraGrand or TerraHub, which I'll be talking about next, where you have a hook before you actually run your Terraform code. It does that action, right? So you can have a hook for before a particular action, you have a hook after the particular action. Number 4, execute in parallel the automated workflows. Here's an example. So instead of, so technically Terraform allows you to parallelize and to increase the parallelism, right? This is the dash parallelism value. But that works only on one component that you're running or one Terraform configuration that you're running. When you have multiple configurations, Terraform out of the box is not able to handle that, right? So that's one of the orchestration tools that I mentioned about, and I'm also contributing into, is if you're running TerraHub apply, it will run you the in parallel, right? Depends how big is your processor. 8, 10, 12, 20 components, right? Very often, we don't need to run these automated workflows for all of the components. Like, for example, you defined some piece of your infrastructure, you have, let's say, 10 components, right? But as the best practices in the automated CI/CD pipelines, you don't want to wait until all of them goes through the execution of the workflow, so that after each step you see, for each component you see that, oh, I actually don't have any changes. So that's why we've done some integrations with the Git diff. So basically, when you define a component and you use an orchestration tool like TerraHub, you are able, instead of running it on the entire project, I have here the security Terraform project with 10 components. I identify by running git diff on the code, and I see that only 2 components changed. The other 8, I didn't do anything to them. So suddenly my execution will be actually much, much, much faster, but also much more optimized, right? Now, next, separating environments or workspaces. Here's where myself personally and Anton don't agree. I agree with one thing. If you want to run your Terraform code and you want to manage all of your environments, you can write specific environments. If not, you just run your development environment and you make your Terraform code immutable. Right? Everything that changes, you put in your TFVAR files. And then you can use orchestration tools or automation tools like TerraGrand, and you can specify that my development environment is default workspace, right? But then my testing environment is the workspace testing or QA or whatever name you like better. My pre-production environment is stage or UAT, or again, whatever you like better. And then my production environment is prod or master or whatever, right? And then you can tie that to any version control systems, like Git or Subversion, and then you can have a mapping between this is my structure of branches that I want the CI/CD pipeline to automatically deploy into the corresponding environment of my application. All right? So that's what basically we had before coming with this pattern, and that's when Terraform, when HashiCorp and the Terraform community introduced the Workspaces, that's where it gets into like simplifying, right? Okay. So we're pretty close. The seventh best practice is using variable precedence. So this is another thing that is native into Terraform. If you want in the same execution, you have multiple environments like Workspaces, right? And you want in the same execution to define variables, but the values will collide, right? So Terraform variable precedence will basically take the last definition or the last file that is specified in the command line will take precedence over the previously defined variable. So like in this case, I have account ID, region, S3, well, all of them, they technically collide, right? But if I run Terraform apply with the var file, the first from the top, I get something like that. But if I run with this one, and you see in the, I'm not sure the guys in the back, you can see I'm actually specifying twice the var file, so that everything that I have in the second var file that collides with the values from the first var file will override that values, right? Again, this is very useful when you're running Terraform in different automations. Again, you're managing having values put in the files and like running the default Terraform vars as first, and then additionally you put them at the end of the command line, right? If you want to learn more about variable precedences, that's the URL. Right? Well, last but not the least, it's an explicit language, right? It's in Terraform, you need to describe everything in pieces of code, right? So you have to be comfortable, getting comfortable to have a lot of code. Or you can use some of the orchestrations like the one that I'm talking about, TerraHub. If we're using a YAML definition of Terraform or JSON definitions of Terraform, you can reduce your code base by at least 30, 40%, maybe even more, depends on the use case. So one of the examples, real examples of a project that we worked on, we reduced the code base from almost 34,000 lines of code into a little bit below 20,000 lines of code, right? So that's a good improvement from my point of view. So just to summarize, right? Microservices architecture, that helps you with the automation, as well as it helps you with when you get into debugging mode to see what are the problems with your code. It's easier to try to figure it out, right? Pass variables, not just hard-coded values, but use the Terraform remote state, right? Avoid local provisioners and external data. Execute your Terraform code in parallel, like use auto orchestration tools, right? Use an optimized way of doing that, right? Even if you don't use an orchestration tools, you can put together some shell scripts that instead of looking to all the things, it just looks the git diff between your commits or in your pull request and runs the Terraform only to the code that changed, right? Logically separate environments with the Terraform workspace, right? Use the variable precedence. That's a native feature in Terraform. And last but not the least, either get comfortable with lots of code or use it on orchestration tool like TerraHub CLI. So that's basically all the lessons learned that we've done in the last 2 years. We've put together in this CLI, and it's open source. You can go take a look into this code. So that's all about my presentation. Now I would like to spend the rest of the time doing a hands-on demo. Hopefully the demo will be successful, as well as answer your questions, okay? All right, so, before I switch, so the demo that I would like to show or present today is actually a Terraform module that was designed and written for managing AWS Landing Zone. Who is familiar with AWS Landing Zone? Raise your hand. All right, that will be fun. Who has more than one account on AWS? Okay. Give me some shout outs. How do you manage multiple accounts besides manually, right? Hands-on. Do you have any kind of orchestration? No. All right, so those of you who have multiple accounts, this will be interesting. Everybody else, I don't know. Hopefully the process will be interesting for you, and you can learn from this, because the same concept applies to other cloud providers. Right? Okay, so AWS Landing Zone is a solution from Amazon Professional Services that allows you to manage multiple AWS accounts in a secure mode. Right? At least that's what they talk about. So let me actually then open this web page first, and 1 second, I think. All right. So this is the URL. Right? What's important for me as an engineer, right? So this is the thing that I was talking about, right? You can set up really quickly. You can do it in an automated way, not just manually. What's important for me as an architect is this thing. Let me try to do like this. Okay? So this solution allows you to manage a pretty unlimited amount of AWS accounts. It doesn't matter how you organize it internally. I've worked with customers that they organize internally by business unit. And each of the business unit has a production account and non-production account. If the company has 10, 12 business units, that's already at least 24 accounts, right? Then you have other accounts that are given to innovation groups, right? And those guys open up a couple of accounts. Then you have some groups that decide to give accounts to each of their developers in their organization. So really quickly, you can go really crazy, right? It doesn't matter how you organize those accounts. What it matters is that instead of putting barriers in front of engineers, you are making boundaries for the engineers, right? Every organization cares about their security. So you set up everything security related in a separate account, and then you enforce those security boundaries on all the other accounts. Every organization cares about monitoring what's happening and being able to audit, right? So you need to collect logs and be able to visualize them, or even set up some automated tools, DevSecOps tools, let's call it, that will respond really quickly to incidents, right? And last but not the least, especially large organizations, they have a lot of legacy. They still need to piggyback to their existing data centers or like legacy environments where they either get some data or expose some tools or expose some platforms, applications. So they don't want just to get everything into the cloud because it's expensive. It takes a lot of time and so on and so forth. Okay, so this is this is what a landing zone is from AWS perspective. Now, if you'll go home, you'll see, if you're looking at multi-account, how to manage multi-account, on AWS, there is a service called Control Tower. That service was announced last year. It was released 2 months ago, which literally implements this solution and adds up 70 more integrations, right? So in case you're going home and you're like, why we talked about landing zone? Because there is something new and shinier and better. So let's start with VPC. And you see how many solutions you have for VPC, how many modules you have here for VPC. The one that Anton wrote, it's not here. That's why I was looking for VPC. All right. Next time, Anton. Let's search for landing zone. Okay? Only one. So this is the module that I'm talking about. All right. This is what I will try to demo it today. This module provides actually under one umbrella 3 different modules. One is designed if you are part of the organization who will be actually doing that, that's great. You can take the landing zone module and that will solve technically your problems. If you are the one who are actually wants to consume the data from the landing zone, those are the other 2 modules are for you, the reader and the reader config. Okay. So without further ado, I would like to go here, and I would like to do like this. So technically, I downloaded the entire module from GitHub, right? And I'm using Terraform version 12.9, and I have a couple of providers over here. Guys, can you see at the back? Is it big enough? Should I make it bigger? Yep. Okay. All right. So, as Anton was showing earlier, oh, come on. Terraform init. Okay. Downloaded all the providers associated with that. One thing that Anton didn't show, but I usually like to do that, run a Terraform plan. So the Terraform plan is the command that shows you what will change, right, when you're running Terraform apply. It also shows you in the Terraform apply, and that's where you type yes, or you can run Terraform apply -- auto approve, and it doesn't ask you anything, it goes directly, right? Why I'm mentioning this is because in automation, this is very, very important. You can run Terraform plan as one step. You can collect the plan. You can write testing scripts that compares your plan to actually what you're trying to do. And if you get some discrepancies between what you're trying to do and what you're seeing as a result of a Terraform plan, then you stop your automation. Right? That's what actually we are doing it in our orchestration internally to our customers, and that's why I wanted to bring this up. So one of the things I can do right now, Terraform apply, but it will fail right away. So we don't need to wait for that so that you can see that it will fail. Why? Because I already have some VPCs created. I already have the subnets. I already have a lot of resources that I'm trying now to demo over here. And the benefit of Terraform, and I'm surprised Anton didn't talk about this yesterday in the previous talk, is that you can import existing resources. For example, you can you can create your Terraform configuration, right? But the resource is already created in AWS. Maybe somebody manually created it. Maybe it was built by some other previous configuration tools that you're using, Ansible, Chef, Puppet, and so on. The difference between, and it's an architectural difference, and that's, I personally like Terraform versus CloudFormation, is that I can say, I already have those resources. Import that resource, connect my Terraform code to that resource, And the next time when I run Terraform apply, it will actually see that the resource exists, and it doesn't need to create a new resource. If you don't make a Terraform import, what happens is it tries to create that resource again. And in terms of VPC, because that's how the VPC that resource was built by AWS provider, it will create a new VPC with the same CIDR block. It will not block you from anything. But when you try to make the subnets, it will fail. All right. So generally speaking, if the resource already exists on AWS, it will stop you from creating the resource. Right? VPC is just an exception from that rule. So that's why for me to be able to run this configuration, I will run Terraform apply only for the config side of the module. And what it does, the configuration, is dynamically updates the configs because it reads from the terraform.tfvar file. It reads all of my providers that I defined. It reads all of my configuration file, the path to where I'm storing my TFVAR files. Okay? And it updates internally the Terraform so I can continue using it. So you see here it says done, 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 done. Error. The error is actually, it's an expected behavior. In some cases, if you see here, it actually says dash dash delete. Sorry, here. Dash dash delete. So in cases where this configuration doesn't exist, it returns an error because it didn't have anything to delete. All right. So now I have my module configured. Now I can just go and run apply, right? But as I said, I don't want to do that. I don't want to waste your time as well as mine. I will try to do some imports. And I will show you the script while it's importing. So I'll do the importing of VPC and subnets. Okay. And the import of the VPC subnets, it actually takes each of the provider that was defined in the module's provider variable, and it takes each of the paths to TFVAR files for each of the provider. Okay. So why it's important to take a look at this? You need to understand how Terraform works. So first, Terraform is built by providers. Every provider builds their own implementation on Terraform. Terraform internally just gives you a centralized workflow or a centralized sets of command scripts, right? You can do Terraform init, Terraform apply, and what? Okay. I know what happened because I was preparing for myself for this presentation and I didn't clean up them. So live fixing of a code. Okay, VPC, subnet, and that's it. Yeah, it's not it. So I need to run landing zone VPC. It will actually show you that everything that I said, it tries to create those VPCs, but I already have them created. And I have subnets in this same script. All right. After I'm running this, the import script, you should be able to see. Yeah, it says here that it tries to create 28 subnets. Right? So now I'm doing import, and as I promised, I will show you what this import file will look like. So These are sets of commands that you can run in order to import existing resources into your Terraform configurations. So coming back to what I was saying about how Terraform internally works, right? So every provider, AWS writes their own implementation of the providers, Google runs their own implementation of providers, Microsoft runs their own implementation of providers, and so on and so forth, right? Now, you as a user of Terraform, you're running Terraform init, Terraform Plan, Terraform Workspace if you want, Terraform apply. Terraform destroy if you want to clean up your resources from your cloud provider, right? Now, you do that manually. Well, manually, I mean, you write the code. You are comfortable with the code. Now you're trying to push into a pipeline, right? You run not using your local computer, but you want to use, I don't know, a service from Jenkins, right? Or CloudBees, right? They're somewhere here today. So you need to put into automation. And that's where it becomes tricky. You need to put Terraform init, Terraform, let's say plan, maybe you will not be using it, but although you should, Terraform apply. Right? These are just scripts that some of them might fail because, for example, on the provider side, some of the implementations, or you might hit a limit of requests per second or limit of transactions per second and so on and so forth. All of those things you need to write in your code in order to do automatic retry if it fails, right? Or if you see that the results from the Terraform plan or even Terraform apply, you get some errors, you want to stop your automation, right? So Terraform, my point is that the Terraform doesn't allow you in your code to loop through providers because the concept of Terraform is that the providers are different, right? AWS is different from Google, is different from Microsoft, and so on. On the other hand, when you're using one provider, AWS, right, and I have multiple accounts, the only way I can do that in Terraform is by actually saying, oh, I have multiple providers, and they are all different. I have an AWS provider that is for my account A. I have another AWS provider, but it's for account B. I have another AWS provider that is for account C. More than that, if you want to use one provider, but in different regions, guess what? You need to update the provider. You need to break it down. So suddenly you're having, if I'm an enterprise, usually that's a requirement to go across 2 regions at least. If they're global companies, they're going at least 3 or 4. And I want to have consistency across the board. So the biggest that we were able to go is 40 accounts, each of the accounts going into 3 regions, so you already have 120 accounts. Not all the resources gets deployed, all the same resources for consistency purposes gets deployed across all these 120 providers. But coming back, Terraform doesn't allow you to loop through providers. So what you need to write, let's say 120 different resources doing exactly the same. Right? So that's one of the benefits that the logic that we implemented here in the landing zone, where you actually are looping through providers because they're the same provider, just different accounts and different credentials. All right? So now that I'm imported all the resources, I can show you that before, when it was asking me to create a VPC, new VPCs, now it will actually read those VPCs from my accounts, and it should tell me no infrastructure changes. Okay? So if I do Terraform apply, now instead of 3 resources, it tells me that I want to add 2 resources. Can you click on that one? How much time? It's dead. All right. So I know it's a little bit hard to explain when I need to go into the basics of how Terraform works and how Terraform in an automation works. I can send you at the end, share with the group the links to documentation where it's documented either on the module side or directly on the Terraform documentation website, how to run Terraform in an automation. And you'll see there are a lot of things that you need to think about that will help you. So, coming back, this is just the first component. If I am the one who needs to manage it, so in the Terraform module, in this landing zone module, we are managing all the VPCs, all the subnets, all the routes, all the gateways, internal gateway, custom gateway, private gateway, direct connect, transit gateway, all the IAMs, IAMs roles and policies and attaching the policies, all the SAML providers and SSO providers, well, SAML is a standard, not actual providers. Am I missing something? Yes, and all the pipeline, the automation, how to put that into an automated mode. Right? So that's a lot. The benefit of it, you don't need to do all of these things. The module is doing everything for you. So that means you saw all this, a lot of things. That are the outputs from that provider. Now, just 2 minutes, okay? I want to show you if you are actually a user of this provider, of this module, right? So for the users of module, you probably will not be doing all this crazy thing that I just showed you over here. Everything that you need is just to use this component, right? So for example, I want to show you the demo right now, launching a Lambda function. And Lambda function, what you need is 3 components. You need a subnet ID, or multiple subnet IDs. You need the security group, or multiple security groups. And you need an IAM role. So all of that technically will be provided to you by the module, right? So first of all, in the in this reader config, it's similar to the actual module. It centralizes all of the information that it receives from the module, right? It does all the configuration of your automation, and then it spits out into a JSON file everything that it collects from all of the Terraform components that you have part of your landing zone. All right. So this is important step because that will be done in the next demo. And while it's doing it, let me pull up the demo. And this is the demo, right? So as Anton mentioned earlier, instead of writing a lot of code, this is what you'll be writing in your code, right? And if you're using serverless, will be more or less the definition of an AWS Lambda that you'll be using in your serverless environment, all right? And as you can see here, for role, I don't have a hard-coded value. I have a local variable that reads it from the landing zone. Same for security groups and subnets. It reads from the default. That's the workspace. That's my default workspace. Technically, that's also the default provider in this case. But you can extend it to use multiple providers and multiple workspaces. Come on. All right, cool. So I go back to my example. And here I do Terraform init. All right. Then I do Terraform plan, just to show you that it will be created. So I showed you the code. This is a variable. This is a variable. This is a variable. If I show you in what Terraform will actually do, That's changed with a value. This is changed with just one value, but the subnets, there are actually two subnets. And if I do Terraform apply, and do yes, it now creates me the Lambda function, and let me remember, AWS Lambda, invoke. I was trying to invoke the Lambda function. Let me see if I have it over here. Oh, yes. I do have it over here. So I invoke this, my function. I know how much time exactly it will take to invoke the function when you do it the first time. It takes a little bit, couple of milliseconds, sometimes seconds. Where is that? Oh, there you go. And then here's the actual result that I received. Hello world. All right? All right, I'll stop here. Before I stop here, if you don't need it anymore, you do Terraform destroy. It will tell you what it will delete, and it will ask you to delete. All right. Back to the demo. Back to the slides. One thing that I want you to take away from this presentation is this quote from the CEO of AWS, is there is no compression algorithm for experience. Thank you.